Hey you guys, this is just a quick lesson on exponential functions. It's something we look at in Math 980, but this is 1010, so it'll be a little bit different, but it should be something you're pretty used to. So thanks for watching. Don't forget to like, comment, and subscribe. They should look something like those purple lines right there. They are 1 to 1, right? So for every x value, it has only one y value. And for every y value, there's only one x value that corresponds with them as well. The y-intercepts are generally at 0, 1. That can change. But this is, again, just a very general idea of what it looks like. There's no real x-intercept, again, unless we change the function a little bit. The domain, if we were to look at both of these, they go infinitely to the left, right? But they also go infinitely to the right. So the domain is from negative infinity to positive infinity. And the range, notice this 0 is not included. That's because that purple line will never actually touch the x-axis. Okay, and that's where we get something that's called an asymptote. Why is it called that? I don't know. All right. Asymptote. I'll write it down. The asymptote is showing that it will never cross this. I'm putting it in green, that green line right there. And it works for the other one as well, right? If I made that green line right there. If I had drawn that more accurately, it would never touch it. But it's hard to when it gets really close. It will get really close. The line will get really close to that asymptote, but it will never actually get there.
And you could have one for the y-intercept as long as it never asymptote.
So you guys are getting into that stuff. We'll see a little bit later. We'll see some that kind of look like this. Right? And now we can see that the asymptote is more a vertical line instead of a horizontal line. Yeah, so it's going up really fast, right? Okay. But it's also still angled there, so it is still going to the right. Not an asymptote. Okay. So I mean, if you said, well, what's the value when x is 100 million, something like that, you could find a value. It's humongous, but there is a value that corresponds with that, and it goes all the way to the right. It goes through. Because we're kind of used to seeing the stuff kind of just, I guess even with these ones, right, you'd think that it kind of goes straight up, and it looks like it does. And that's just because it's increasing so fast, which is why things, I guess the saying goes, it's growing exponentially. All right, when actually graphing these, oh, there's asymptote, spelled correctly. When you graph these, okay, find 2 points. Usually the y-intercept's a pretty easy value to find, all right? And we'll talk about that. But we do want, the 2 values will kind of show the pattern. The 3rd value will confirm the pattern. Because if you were drawing this line in purple, right, you can say, oh, I got my y-intercept here, and I got this other point. Let's see what the next one does, and it's down here. Then you did something wrong, okay? Now, the question is, we just don't know which one it is. So you may have to go back and redo that one, or the other 2, one of the other 2. But again, you want to confirm that pattern with 3 points. Exponents. If I saw 3 to the power of x, I can feel pretty good about that, right? 3 to the power of anything I can find. I can even plug it into my calculator. The problem is if I see negative 3 to the power of x, we interpret that as it's negative 3 to the power. But it's really the negative of 3 to the power of x. And the negative is on the outside. That's correct, yeah. So this one, you'd want the parentheses like this, or, I mean, you could have it like that as well. So, yeah, just be careful with that. We need to see parentheses before we start making this assumption. So, that's a very small formality, which gets a lot of people. So be very careful about that one. Okay, I apologize. I made an assumption, right? So, formally, exponential form looks like this. Y equals b to the power of x. Why do they use b? Because that's called the base. Why do they use x? I don't know, because we're used to using x. Exponent. And yeah, you could say exponent if you want, right? Exponent. Make sure I spell these ones right. And then y is just your answer for that, right? So they're in this basic form right here. Now, the 3 and negative 3 stuff is just to acknowledge that the base sometimes is negative. But sometimes it's just the opposite of the base, which is the difference of what we were talking about there with the red expression. Is the opposite of 2 to the power of x. And if it does help you to put the parentheses in there like that, I mean, go ahead and draw those in there. But we do need to understand the difference between what we see right there in that set of parentheses and then what we see right here with this set of parentheses, because they are very different. So when I graph these, I like to just make a table, and base 2 is not too bad. Well, again, if we can just do this with 3 points, x and f of x, right? X and y is a t-table, regular stuff. So we'll look at the y-intercept. That's where x is 0. And we can just try 1 and 2. We can go for convenience on these, right? So when x is 0, then f of x would be f of 0, which is really negative 2 to the power of 0. And we've gone over exponential rules, or exponent rules. Anything to the power of 0 is 1. But this is the opposite of 2 to the power of 0, right? So it's really the opposite of 1. So that would be negative 1 right there. All right, well, what about when x is 1? We'll do this one in green. So then I've got f of 1 is negative 2 to the power of 1. Well, 2 to the power of 1 is 2, but I'm taking the opposite of that. So I got negative 2. So that is my y value when x is 1. And then finally, x is 2. We'll just do that one up here in the top left. 2, negative 4. Well, I've got these 3 points now, which I should be able to graph. 0, negative 1, right here. 1, negative 2, down here. And 2, negative 4, down here like this. Now, we could have continued that, by the way. Right? We could have found 3, and then we would have had negative 8, and then 4 is too big for that. So again, that third point, that blue point, confirmed the pattern. It's really just kind of going down. It's going down really fast, right? Well, what happens to the left of this line? So let's give ourselves some space. So let's go to the left. So let's make x negative 1. And if we need it, x is negative 2 as well. So when x is negative 1, then I've got negative 2 to the power of negative 1. 2 to the power of negative 1 is 1/2, but it's the opposite of that. So negative 1/2, right? So negative 1, negative 1/2. And we can see already that it's approaching the x-axis already pretty quick. And then we got negative 2, so negative 2 to the power of negative 2. That's the opposite of 1/4, so negative 1/4. Again, that's very close, especially on a graph this big. And we kind of confirm just with that much that those values are going to get closer and closer to the x-axis the farther to the left we go. And that is our graph. All right, here's another graph. So again, I like this t-table stuff. X and f of x, or f and x and y, rather. All right, and I do try. Well, let's look at the negative value on this just to see what the heck is going on there. Negative 1 and 0 and 1. All right. So on this one, the y-intercept on this one, x is 0. So I'd have, we'll do it in purple, 3 to the power of 0 minus 1, which is really 3 to the power of negative 1, which is 1/3. Okay, again, just going back to exponent rules there. So we got 0 and then 1/3. So 0, 1/3, that's pretty close to 0 already. This kind of creates a problem with negative 1 just because it becomes so small. And that's because up here we're subtracting that 1. Let's go ahead and do it anyways. 3 to the power of negative 1 minus 1 is 3 to the power of negative 2, which is the same as 1 over 3 to the power of 2, which is 1/9. Again, that's a very small number. It's just getting very close 2, 0 already right there. So put that point there in green. The next one, 1, that should be pretty nice. Now we got 3 to the power of 1 minus 1, which is 3 to the power of 0, which is 1. 1, 1. Now that does show the pattern right there. But if we can get something that kind of shows how fast it's climbing there, then it shouldn't be too bad. I'm looking at x is 2. So that's 3 to the power of 2 minus 1, which is 3 to the power of 1, which is just 3. So 2, 3. Again, that wasn't a lot of extra work, but again, it kind of helps us just visualize what the heck is going on right here. So we draw this line, and this one, again, I'm not looking for super perfection, but that should be pretty nice. All right, now we got a fraction, 1/4 to the power of x plus 4, and I guess I never really thought about this, but you could rewrite this one as f of x equals, that's really 4 to the power of negative 1. And then you still got that x plus 4 stuff, right? And if we were to use our exponent rules, we'd do negative 1 times that expression, which would really give us 4 to the power of negative x minus 4. Take it or leave it if you want. I'm not going to use that, but I'm just showing it to you because some of you would say, yeah, I like that a lot better, because we hate fractions so much, and that's all right, okay? But let's say we didn't notice that, and that would be okay. Then we got our x and f of x stuff. Again, it doesn't matter if you use y or f of x for me. So originally it started as x plus 4, but it is a fraction, so we kind of wanted to switch, right? And if we remember back with just the basics with what the graph of exponentials looks like. If the base is a fraction, then it should have something that looks like this. Okay, so we should expect to see something like that. Again, that's because it's a fractional, and then with the negative exponent thing, once we get into x's that are negative, it's going to make it increase pretty fast. I don't expect you guys to memorize that stuff, though, okay? So let's look. Let's just try some value. Let's try x is 0, all right? Just see where that takes us. So that would be 1/4 to the power of 0 plus 4. 4. So that's really 1/4 to the power of 4. Well, 1/4 to the power of 4. That'd be 1 to the 4th over 4 to the 4th, which is 1 over 256. Bam, that's pretty close to 0 already for my y-intercept right there in purple. All right, so 0 and 1 over 256, that's pretty good. The question is, from here, do we go to the right or the left? Now, again, just looking back at the general or the basics for exponentials, if we go to the right, it should get closer to 0, and we can confirm that, right? Like if I said x is 1 here, then I get 1/4 to the power of 1 plus 4, which is 5. So that, again, I'm just showing that to confirm that that value is going to get even closer to 0 the farther to the right we go. All right, so we need to move to the left and find some values to work with there. I'm going to go all the way to negative 4. And you may be asking yourself, why negative 4? That's because the negative 4 for x right here is going to cancel out that plus 4, which really is going to give us 1/4 to the power of 0, which is pretty easy to calculate. Now let's show the work on that, though. There we go, 1. So I got negative 4, 1. And this should increase the farther to the left that we go, right? Let's look at what would happen if we chose negative 5. So if we did that, then we'd have 1/4 to the power of negative 5 plus 4 is negative 1, which just inverts that, or I'm sorry, reciprocates that fraction, which is just 4. So negative 5, 4. again, it's going to have that shape that we thought that it would have in the beginning. So let's go and draw this out. All right, this is the opposite of 6 to the power of x plus 1 because there's no parentheses, right? So we have to keep that in mind when we're solving for these values of x and f of x. Again, you can use y if you want. Now, x plus 1, that's not too bad. If we said x is 0, just for a nice starter value, then we got negative 6 to the power of 0 plus 1, which is negative 6 to the power of 1, which is negative 6. 0, negative 6. Bam, there it is. All right, what if we said x is, so, right, we got this x plus 1. So let's make x negative 1 and see what happens, all right? Should turn out pretty nice, by the way. So that's the opposite of 6 to the power of negative 1 plus 1. There we go. Which is negative 6 to the power of, 6 to the power of 0, the opposite of that. 6 to the power of 0 is 1, and we're going to take the opposite of that, which is negative 1. Negative 1, negative 1. All right. So, which way do you guys want to go? Do you guys want me to go more negative or more positive? All right, let's try negative 2 then. All right, negative 6 to the power of negative 2 plus 1 is negative 6 to the power of negative 1, which is the opposite of 1/6. So negative 1/6, negative 1/6 in the table. So negative 2, negative 1/6, about right there, maybe. All right, so we see it's going to get close to 0 the farther to the left that we go. So let's go ahead and, well, I guess I can draw that much of the line. Right now, something like this. Let's go to the right, so we'll use 1. So I got 6 to the power of, the opposite of 6 to the power of 1 plus 1, which is the opposite of 6 to the power of 2, which is the opposite of 36, which is too far down to put on the graph. So we just put the line like that with an arrow indicating that it's decreasing extremely fast. And there we go. Now on the homework we're going to see problems like this, but it's also going to ask for the asymptote. Specifically the equation for the asymptote, all right? Now, since this is getting close to the x-axis, and we can draw that up. So there's the asymptote in purple. That's a horizontal line, which indicates that it's some x value. So it should be x, there we go, x equals something. I'm sorry, I said x, didn't I? I meant y. Thank you. Let's get rid of that x. Yeah, because this is on the vertical number line, so it should be y equals something. And if we look at that number line, that's where y is 0. So that's that horizontal line, y is 0, when it asks for the asymptote. All right, find the asymptote and y, and it should say y-intercept for this one, and we'll draw the graph as well. All right. Just out of curiosity, we got that -4 right there. What do you guys think that's going to do to the graph? If we were to compare it to something like 2x minus 4 with 2x, right, because we could show that as plus 0. It's just moving it down 4. So we should expect this to move down 4, right, with that 2 to the power of x minus 4. All right, so let's create our table. All right, students' choice on this one. What values of x do you guys want to use? All right, let's try x is negative 2. So that's 2 to the power of negative 2 minus 4 like this. 2 to the power of negative 2 is 1/4 minus 4 will be negative 3 and 3/4, or negative 3.75. All right, let's see, where is that going to be? All right, x is negative 1. So that's 2 to the power of negative 1 minus 4. 2 to the power of negative 1 is 1/2, then minus 4, right? Just order of operation stuff. which would be negative 3 1/2. So we'll write that in, negative 3 1/2, negative 3.5, whatever. Negative 1, negative 3.5, all right there. Not a lot of change between those 2 points, but it will start changing pretty quick. So what other value do you guys want me to use? All right, positive 3, that's 2 to the power of 3 minus 4. 2 to the power of 3 is 8 minus 4, which is 4. So we have the point 3, 4. That's very nice. Now we should also try to find the y-intercept. That one's not too bad, right? 2 to the power of 0, 2 to the power of 0 minus 4, which is 1 minus 4, which is negative 3. So 0, negative 3. I don't know. I mean, the 3 points we had kind of confirmed the pattern. But that gives us a pretty good visual. And we could figure out 1 as well, right? Sorry, I should write that in. 0, negative 3. Let's just show the points there. All right, something like that. All right, find the asymptote. Well, yeah, this is getting close to negative 4. Let's draw that in. Now, does my line cross or touch that asymptote? Yes, it does. I'm sorry, I can't get, I can't go too microscopic on this. But, again, on an exam, this would be fine, all right? Well, what's the equation for that purple line? So, again, it's horizontal, so it should be y equals, because we should look at the y-axis as its own number line. And where is it for y? It's at negative 4 on that number line. It's just one way to look at it. I mean, we should be able to find equations for horizontal and vertical lines by this time as well. That is the asymptote. We did find the y-intercept as well, right, from this question at 0, negative 3. And if we wanted to, we could, right, well, here's an arrow pointing to it, whatever. Given this function, evaluate f of negative 5. All right, so I'm just going to go in there and replace the x's with negative 5, right? Well, I can plug this into my calculator directly, as it turns out. 880 times 1.3 to the power of negative 5. Just be careful, right, because the order of operations, you're not going to do 880 times 1.3 and then find that power of negative 5. You got to do 1.3 to the power of negative 5 first, and then multiply that by 880. Again, that's just order of operations stuff. That's what I got. Again, that's just plugging it into the calculator. So hopefully that's what you got too. This one has a lot of words, but as it turns out, it's going to be very similar to that last problem. Cassandra has a headache and takes 450 milligrams of Tylenol. The amount A of Tylenol remaining in her body after N hours is given by this formula. Sorry if that's not actually the way it is. Some people get real technical about that. I'm nerdy in the math sense, not the medical sense, so I apologize if that's wrong. However, that's the equation we have. How much of the Tylenol remains in her body after 6 hours? Round your answer to the nearest hundredth. All right. It did say that n was number of hours, so number of hours is 6, right? So the amount is going to be, it's the same function, but we're replacing n with 6. And we're replacing the n with 6. So again, we're just going to evaluate this on our calculators. For mine, I got to do 0.81 to the power of 6 first, and then I'll multiply that by 450. Again, that's order of operations stuff. And I get 127, nearest hundredth, 0.09. I gotta point this out because on the last exam people forgot to label stuff on word problems. I think there's only like 2 of them. I don't want you guys to lose those points, so just put it was milligrams. So 127.09 milligrams left after 6 hours.